your curiosity right.
Mad Bricks webcast,
Where the human spirit flies. Mad Bricks webcast, where the human spirit flies.
Welcome. Welcome to the Medbix webcast. I'm the host. This is Ramana Annamaraju. We have very important guest and a very respected, very well-known, a legend is going to be on our show today. I'm really, truly honored for that. But before that, let me introduce you my co-host, Susan Davis. I will always call her a tagline, bold, beautiful, and brainy. All three qualified. Let me bring her to the table. Susan, welcome.
Ramana,
Welcome to the Medbix webcast.
thank you very much. Thank you very much. How are you this
I
evening?
met Dr. This is our guest, Dr. Wesson Ashford. I met him in the longevity conference. It was so impressive. Talking with him we were talking about one of the book I read a long time ago. It is a Michael Talbot wrote, The Holographic Universe. It's a book. That book, in the book, they mentioned about Carl Pribram. He said that he worked with him and all those things he was talking about it. So I think he's a remarkable guest we have. He's a pioneer in every way. So you're speaking with him off the camera. But I tell you something about him. He's a very high presence, and his ideas are very crisp and clear. That's one thing I like about Stanford doctors. They're very good in communication. It's no question about that. So let me bring our great guest. Actually, let me introduce you to you. He has a long. I need to read about him. I tell you, it's a long thing. So.
I'm already worried because he was teaching us a few nuggets right before the show went live, and I'm already forgetting half of them. So I feel like I'm failing the memory test already.
So let me introduce you. Dr. John Wesson Ashford. He told me make sure that I call Wesson. He said that it is John Ashford, there's a football player, I think he's coming up sometimes. He's a true Californian. Now he wants to move to Florida, where Susan is. He was born and brought up in San Francisco, California, went to Berkeley for a degree, then Los Angeles, UCLA, where he obtained both an MD in psychiatry at UCLA Brain Research Institute and PhD in neuroscience. Think about that, Susan. Now, professor at Stanford, as a fellows working for him, pioneer and a trailblazer in unraveling the mysteries of the brain. Dr. Ashford is the chair of the Memory Screening Advisory Board of the Alzheimer Foundation of America, and a senior editor of the Journal of Alzheimer's Disease, director of the War-Related Illness and Injury Study Center in the VA Palo Alto Healthcare. I'm truly honored to welcome him. Let me bring him to the table, Dr. John Wesson Ashford. Welcome, sir. Welcome to the Medbix.
Thank you so much for inviting me. I'm very honored. I suppose I should say first is that nothing I say should be interpreted as anything related to VA policy. So that'll be the first disclaimer.
That Dr. Ashford, it is a really privilege to talk with you. You are such a pioneer. More I read about you, more I get impressed. That you're really thought different, out of the box thinker. Even when you're a child, I can tell that when you're in college. So event against the memory is kind of a retrieval process. It's a neural feedback, loop feedback that you said. Just talk about the memory retrieval, a little bit about memory retrieval, Dr. Ashford.
Well, it's an interesting subject. To talk about memory, of course, we're talking about the brain's function. I think the brain's principal function. And we're talking also about neuroplasticity, which is the capacity of the brain to change constantly to accumulate new information. And there's specific areas of the brain that are most involved in storing that information. and there are other areas of the brain for making decisions. And there's many different directions I can go, so you have to guide me a little bit. But the issue about learning, and you were interested in trying to tell me about this Hopfield network, and that
So
seemed to
we
be new. So maybe I can respond to that a little bit. This is it's a little bit of a dangerous area for me because artificial intelligence is, and different neural network layers and how you can, come up with, cognitive processing using neural networks is certainly an interesting area. Not something I've gotten into. I know my father didn't have much to do with computers, and I took computer classes at Berkeley, and then my 4 children, they're all into artificial intelligence and chat GPT, and I have no idea what they're talking about. If I need something, I just ask them to do it for me. But the thing that I did that is most related to this particular network thing, and it's much more complicated than what I'm going to tell you, but is that the brain stores information. So, I mean, before you're born, tremendous numbers of connections are made in your brain. And then after you're born, there are new connections made and old connections are lost, to the point that the most connections in your brain actually are around the age of 2 years old. And then there's a gradual decrease in the number of connections in your brain until you're about 30, where you about have half as many as you do when you're 2. But it's much more complicated than that. The thing is that the way the neurons work in this Hopfield network that you were trying to tell me about,
Don't worry about artificial AI.
the brain is much more complicated than that. So what I was learning, before I started my dissertation, is that information was processed and, would come up through your eyes, through your ears, through your senses, and would go into your brain, first into your brain stem, and then would be transmitted up into your cortex, into a primary area, and then a secondary area, and then a tertiary area, a third area, an association area. And so I was in this sort of awkward position where and I have like a lot of stories I can tell, but it's like my first interest I was enjoying life, and at Berkeley I was enjoying life, and my major issue was to try to figure out how to live forever. And that's a tragic story.
Do tell, Wes. Do tell.
Yeah. No, it didn't work out. She couldn't figure it out.
Ooh.
But I did try to think about, well, is it the brain that's doing this, and is it? And so I did get interested in aging, and I have a lot to talk about in terms of what the aging process is, and and why how I first thought I'll go off on a tangent. I was at Berkeley. I was trying to figure out how to live forever in my sophomore year. Okay, it's very sophomoric thinking. You have to give me, you have to excuse me for that. I figured I was smart. I could figure this out. So I took some classes on this. And so anyway, Susan's a nurse, so she'll know some of this. I started looking at this, and they started saying, well, the major reason people die is because of heart disease. And I thought, is that right? Is that right? The leading cause of death is heart disease. And I thought, well, okay, I'm going to study heart and see what why people die of heart disease. And people don't get enough exercise, they have lousy diets, and they smoke. And okay, so I decided that as a sophomore in college, I was going to not smoke, which was not a popular decision with my friends, but so it was my decision. And I was going to exercise. I was on the Berkeley swimming team, and then I was decreasing my intake of red meat and cutting the fat off of meat when I ate it. And so one of my good friends from when I was 10 years old, his mother was like a second mother to me. He invited me over to his house somewhere towards the end of my sophomore year, and I was having dinner with him and his 3 older sisters, who always had comments on everything. And his mother served us steaks, and I was cutting the fat off the steak. And his mother looks at me and says, "What are you doing that for? That's the best part." And I said, "Yeah, but I'm got this idea that somehow I'm going to live forever. I'm not going to eat the fat on the steak. I'm not going to smoke. I'm going to take care of myself, right? Of other things that I learned." And she looks at me and she says, "That sounds dreadfully boring. You just get older and older and more decrepit." I thought,
Well,
"Oh, geez."
there's something to be said about, the fat, the
So
sweets
I took courses
in
in
life.
aging, and I became an expert in aging, and there were some very good courses I took, and I'll go into that another later. But so aging was an area, and I started thinking, well, maybe the brain controls aging, and there's the pituitary gland and the hypothalamic pituitary axis, and if I could, maybe that's where maybe the brain's controlling aging. So I got very interested in the brain, and that led me in a lot of directions. But not to solving the problem of aging, but at least to understand what was going on. But I was in my psychiatry residency, and I had gotten interested in the temporal lobe, which controls the hypothalamus. So this was very relevant, and that's where the memories are stored too. Although that wasn't my area at the time, and the hippocampus certainly is a very good part of that. Very much involved in memory, and so I got interested in temporal lobe epilepsy, trying to see if I could manage patients with temporal lobe epilepsy and the problems they had. Well, after my third year of residency, they asked me if I would be the first chief resident on the geriatric psychiatry unit at UCLA. And I said, absolutely not. I am not interested in taking care of old people like myself. I wanted to prevent aging. And they sort of made a deal with me. They said, well, look, we'll let you admit a few of your temporal lobe epileptics onto the unit if you'll be the chief resident. So I'm usually sort of agreeable, and so I did that. Within 2 months, I learned that 40% of the patients on the unit, 2 out of 5 patients on the unit, had Alzheimer's disease, and that affects the temporal lobe, which is where the memory mechanisms are. As I studied these patients, their problems were memory. That was the issue, and memory, the temporal lobe. And so I got very interested in memory at that point. Now, several other things, like including trying to come up with a drug to prevent Alzheimer's disease, because we were the first ones to do a double-blind study of a cholinesterase inhibitor to treat Alzheimer's disease, which is still the current major drug that's used to treat them. So I did that in 1981. I was the first one to do this. But at the same time, after I finished my residency, they asked me to stay on for a year as the associate director, because no one else wanted to take on that position's chair either. And so I was the associate director for a year. But during the year, I started my PhD dissertation, and I worked for a guy named Joachim Fuster, professor who has written the books on the prefrontal cortex. And but I was not really interested in the frontal lobe. I was in the temporal lobe. And he said, "Well, I tell you what, you can put the electrodes in the temporal lobe to see, maybe we can study that in the monkeys that he was training to do memory tests." So that's what I did. And we put electrodes down in there, and it was there was this concept that, like I said before, primary, secondary, tertiary regions. So we put an electrode in the occipital cortex, the primary visual area, and in the infratemporal cortex, the tertiary visual area, where presumably memories were getting stored. And then, of course, they would project down to the hippocampus. So we put electrodes in there to try and measure their activity. And here's where you start getting into understanding the brain and memory and this Hopfield network concept. I wanted to see if the information came into the eye, how long did it take to go from the time a flash or a red or green light that they had to remember, how long did it take to get into the occipital cortex? And then how long did it take to go from the occipital cortex to the infratemporal cortex? Go to BOP, to primary, to the secondary, to tertiary. So I wonder, how long did that take? And I figured, no one had really done anything like this before, so I was going to measure how long it took to go from one to the other. Well, when we gave the flash which was the alerting flash. The monkeys had to remember if it was a red or green light, and then they'd have to choose red or green later, 10 seconds later. So the flash would be alerting, and then 2 seconds, and then the red or green light, and then 10 seconds choice. So we gave them a flash to tell them get ready, in about a minute in between the trials. And the occipital cortex responded very quickly, but the infratemporal cortex was inhibited. It didn't respond. Well, when the red or green light came on, the occipital cortex was activated, but the infratemporal cortex was activated simultaneously. The two areas were both active simultaneously. It's not like information went from one to the next. They went to both areas at the same time. And the implications turned out to be tremendous. So we put electrodes in. About half of the neurons that we would record from were responding to the red or the green light. And I had another friend from Japan that was actually doing some work in this area. And when he put electrodes in the same area and showed the animals a bunch of different objects, like a glass or an animal or anything he showed them, or a table, that about half of the neurons responded. Now, the thing is, in a little area like the temporal lobe, we were looking at the anterior temporal lobe, that just say, let's say 1 billion neurons. And if half of those would respond, now they can respond at a rate of 1,000 times per second, like that. And so the question is, if you've got 1 billion neurons and each one can fire or not fire, the total number of ways that that area of the brain can fire is 2 to the billionth power. Now, 2 to the 100th power is all the particles in the universe.
Yeah.
All the protons, neutrons, and electrons in your body, the world, and every star in the galaxy, and every galaxy is probably not much more than 2 to the 100th power. And your brain has the capacity to fire at 2 to the billionth power in that area.
Just in the one area, in the little temporal area.
That happens to be activated at that time. You've got about 100 billion neurons in your brain. You've got about 10,000 connections on the average between the neurons. 10,000 times 100 billion, that's a quadrillion. And then, okay, that's a lot. But it turns out that in the cortex, the half-life of those neurons, of the connections, of the synapses, is about 100 days. They're turned over at a rate of about 10 trillion per day. And then in the hippocampus, which is sort of a smaller area, but very much involved in memory, they may only last 15 minutes. So all of a sudden,
there's a short-time memory, right? The hippocampus is a short-time memory.
Well, the hippocampus is involved in memory. So I mean, there was a patient named H.M. that was studied up in McGill in Montreal, that had both of his temporal lobes, the parts of the hippocampus removed on both sides, could remember everything before the operation and could remember nothing after the operation. Never remembered a new thing. Remembered everything in the past quite well. So the hippocampus is absolutely critical for forming new memories, but that's not where the memories are stored. They're stored out there in the temporal lobe, where you got.
I don't want to interrupt you, but is important thing is that there is a myth. If I think about my father, I think about a picture stored in my brain somewhere, but it's not true, right? It's not a picture stored somewhere. It is a dynamic relationship that what you invented, what you describing is that am I in the right direction?
Well, yes, but the thing is, then you get down to your hot field network and how do the memories get formed? And the thing is how the memories get formed becomes the big issue, because what's happening is when you stimulate the brain to remember something happens in the brain that changes things. Now, if I'm telling you some boring story and you're not paying attention to me, nothing's going to change. Hopefully, I'm getting you interested enough so that something will change in your brain. But as you go through this, And the half-life of the synapses in the hippocampus, like 15 minutes. So huge dynamic neuroplasticity, constantly changing. And so you can imagine 10 trillion neurons, 10 trillion synapses, new synapses being made every day and being lost every day. There has to be a turnover. So you have to produce new synapses, but you can't just produce new synapses. You have to get rid of the old synapses. So that, because I said between 2 years old and 30 years old, you lose half of the synapses in your brain. So it's going down, but it's going down a very small amount relative to the huge amount of turnover that's occurring. And as it's happening, the axons, which is where the outputs are from the neurons, and the dendrites, where the information is coming in, are constantly searching out to see what is the best connection. And when you see something like your father say, your connections say, hey, I recognize that. But if you say, wait a minute, my father's got a new hat, then you're going to be adding some new connections to put the new hat on your father. And those connections are going to involve, a few billion neurons forming new connections. And the connections that are of your father with some hat he doesn't have anymore are going to get lost. And the connections are going to be made to incorporate the new hat with your father's image in that area of the brain that is doing this analysis and doing that remembering.
In the hippocampus area that is doing the
hippocampus. So we put the electrode from the temporal lobe, then we went down and looked at the hippocampus. Hippocampus is firing at the same time also. But the hippocampus is sort of what's saying, wait a minute, this is new information. And then there's something, there's something called an evoked potential. So if you look at the brain waves and you look at something new, there is a particular wave that goes through, if it's relevant, if it's new, different, interesting. A guy named Donchen in Illinois described this, the University of Illinois. He had a paper called Surprise, because when you get surprised, this wave gets generated. When the new information comes through, like, I'm surprised to see that hat on my dad, and then that information is incorporated into your brain. With removing, billions of synapses and creating billions of new synapses. So, and out of the 10 trillion that are being changed every day. So constantly changing these things is what's happening. So anyway, that's how I sort of envisioned memory working, was trying to make these connections. But the curious thing about this is that this area of the brain, the temporal lobe, and the occipital lobe, the primary area, fired at the same time, which means that there's something going on. And there, by the way, the connections go back and forth. There's connections that go from here to there and back from here to here.
How is possible, Dr. Ashford, how is possible that both are at the same time? Because the traveling time is there, right? Between the neuron, the electricity has to travel from one place to other place. It takes time. How could be same time it's lighting up? How is it possible?
Simultaneous. He said they're simultaneous. They had the sensors in there.
Is it a quantum phenomena there?
Yeah. Okay. So I tell you what, I'm going to go off on a total tangent here.
Take us.
Yeah, real tangent here. I've already told you this, but
Yes.
Here?
Yeah.
Susan, you know what that is?
It's hard to see the image.
Yeah. Something more than that.
Oh, you're asking me.
Yeah. What is that?
Yeah.
I can't read it. I apologize.
No. What is this?
Image.
What is that?
Yeah, it's a little hard to read. Michelangelo that you showed.
Yeah, I mean, that part I can tell, but I'm not familiar with the picture.
Yeah, Michelangelo's picture.
Very Sistine Chapel ceiling.
Sistine Chapel. Okay.
This is God giving life to Adam.
Oh.
I don't know.
Okay.
I love that. That's wonderful.
Okay, now I'm going to show you something else, because this some doctor in Illinois, in Chicago, was studying art and looked at this thing and said, you know what? That looks like a brain. And I looked at that and I brought this picture and said, yeah, very much into the brain. That's very much relevant. And then then there was this book that came out called The Da Vinci Code.
I remember. Yeah.
And
It's not the movie.
oh, a movie too. Yeah, no less than a movie. So I looked at that and I said, maybe Michelangelo's got something else of interest. And I've already practiced this once with Ron. So I'm going to share my screen.
Dr. Ashford, can you move to the center a little bit? Yeah.
No,
you want to show, you want to keep
He said no.
No, I'm going to share my screen here.
Yeah. Oh, you want to share the screen? Okay.
Yeah.
Yeah. Okay.
So the story goes, Romana.
Okay.
Yeah. All right. Can you see this? Okay.
Yes.
Yes.
You can see it. Okay. So here's God creating Adam, or giving Adam his spirit, because Adam was not like being created. He was already alive. He's touching him and he's giving him his spirit. And you can see sort of, lackluster guy laying there doing nothing, and God's trying to stimulate him here. Well, that's a picture of the brain, and it's just incredible how accurate it is. And I started thinking about this, and well, maybe there's something else in there. And I started looking. This is a very rude picture of God right here. Can you see that? This here pic. That's a pretty rude picture, I always thought. That's just the way a frog brain looks, with the optic tectum right here, represented by God's posterior. And then you've got another picture here that looks like a cat brain, and then another picture here that looks more like a monkey brain. And then back here at the beginning, let there be light. And I thought, well, I don't know, what is that? Well, I finally got a good picture of a dogfish brain that looks just like a dogfish brain. It looks like a fish brain. So Michelangelo described the development of the brain in evolution 300 years before Darwin. And this isn't just my random thoughts. We published this in the Neuroscientist in 2022. I actually discovered this in about 1908, but it took a while before I got anybody interested in publishing it. But we finally did. And it wasn't just that. There's also the Last Judgment. I presume you can see these things I'm showing.
No.
And
All we can see
looked at the Last Judgment.
If you can share that screen, last time you did share that.
Yeah, no, Wes, all we can see is creation behind you there.
Can you add the screen that the last time you shared that one, Doctor?
No, it says I'm sharing.
You're
No,
not sharing.
so we missed the cat brain and the
Oh,
other
no.
example.
What happened here? Because I was sharing. Stop sharing. Start
And then-
sharing.
Yeah.
Share the entire screen. Share this picture.
No.
Share.
Yeah. Now we can. Yeah.
Can I see it? You see it now?
No,
Yeah. That's.
there.
Oh, okay. Well, I'll go back to this one. I'm sorry.
No, that makes more sense. I was like,
Okay,
you're getting all
so
of
this
that
is
from that
God.
creation.
Yeah.
There's God giving spirit to Adam. Okay, he looks just like a brain. And then I started looking at this picture of God in his rear end, and that looks just like a frog brain, because that's where the optic tectum looks on a frog. And then wait a minute, that looks like a cat brain here. And when he's creating the sun and the moon, and he's actually got the optic, there's areas in here look like the optic tectum and things. And then this looks like a monkey brain. I couldn't figure this one out. It turns out this looks sort of like a fish, the one at the bottom. And it looked like a dogfish brain. So here he was Michelangelo's describing the sequence of brain evolution 300 years before Darwin. So anyway, this is, we published that in Neuroscientist 2022. And then just another side thing is that there is the Last Judgment. And if you look at the Last Judgment, Jesus is making decisions, and that's right in the middle of a brain also. And so that's all part of the publication. The reason I'm telling you this, I'm going to stop sharing this. It's in the Neuroscientist. If you want to look at that. Is that it turns out that what we've had to figure is, well, okay, so why do these two areas of the brain?
Please come in the center, Dr. Ashford. Can you come in the center? We can't see you. Okay, now.
There he
Yeah,
is.
that's
Yeah.
good. Yes, sir.
Why do these areas of the brain become active simultaneously? And what we started saying is, well, wait a minute. Your information not only goes into something called the lateral geniculate in the brain, but it goes into the brain stem, into the superior colliculus. And that's what activates both areas of the brain simultaneously. It is not the two areas are coming back and forth, that the brain stem is operating this thing. And this is, Carl Sagan was saying this in the book he wrote called The Dragons of Eden in 1977. That it is the primitive brain, and the cortex is just an extraordinarily powerful supercomputer that works just for the brainstem. And that's all it's doing. And it's saying, hey, some information is coming in, activate this, see if we recognize something. And so the thing is, if you want to talk about consciousness, which I've heard a lot of people trying to figure out what is consciousness recently, it's very simple. I mean, a fish is conscious. A lizard is conscious. And in fact, there's something called the lizard brain. Somebody's talked about recently. But dogs and cats are conscious. The question is, are they awake or are they asleep? If they're awake, they're conscious. The question is not consciousness, it's awareness. Are you aware of what's happening in the world? Are you aware of yourself? Are you aware of other people? And that's where the cortex comes in, because the brainstem says, hey, we're conscious, something's just happened, what's going on? Analyze this for me. And the cortex analyzes the information for the brainstem. And then that's where you've got consciousness. It's consciousness and it's awareness. And so
prediction also, the prediction part is also comes in the same time as consciousness. Awareness is a part of the prediction, sir?
Well, so the brain, it turns out, is the spinal cord is divided into an anterior, into a front part, and a back part. Anterior, posterior. The anterior is where the muscles are controlled. The posterior part of the spinal cord is where all your sensory information comes in. It turns out that as we went from worms to vertebrates, to higher vertebrates, to mammals, that the brain maintains that separation. The anterior under part of the brain, the front part of the brain is where movement is generated. The back part of the brain is where sensation is analyzed. And so the temporal lobe is where information is analyzed, whether it's verbal information, visual information, auditory information, or sensory information. It's all behind something called the central sulcus. All in the back, all deals with sensory information. It involves the hippocampus. It involves the amygdala to determine whether or not it's, how it relates to importance to the person. And as all the sensory information is analyzed posteriorly.
Dr. Ashford, Dr. Ashford, I want to ask you, are you familiar with the Dr. Libet experiment? Libet experiment, that experiment was that determination is a law of karma. He's already determined the brain, you're not aware of it, but his action is already done. Is a Libet experiment, is one of the experiments that done 6 seconds before we aware of the action is already done, decision was made. That's what they say. Do you believe that actually? You think that is?
Like I said, the back part of the brain is where you analyze incoming information and where you remember details. All the details and everything are all in the back part of your brain. The frontal part of your brain, now the central sulcus, the back part, there's something called a homunculus. It analyzes all the information, sensory information from parts of your body. Just in front of that sulcus is something called the primary motor cortex. That is where you have another homunculus that's basically a mirror image of the one behind the central sulcus, but it's all involved in movement, moving your fingers, moving your eyebrows, moving your arms and legs. So the frontal part of your brain is movement. And in front of that area, there's complex movement. And in front of that, well, in the back part of your brain, there's this incoming speech area, and a front called Wernicke's area. In the front part of your brain, there's a Broca's area, which is forming speech. So you form movements, and you can form words. And anterior to that is where you form all your thoughts. And all of this works not with the hippocampus, but with something called the basal ganglia. And the chemical involved in that is dopamine. And when people have a problem with that, they get Parkinson's disease or schizophrenia. Those are all things involved, either movement or thinking that's gone awry. The back part of the brain, when that goes bad, that's Alzheimer's disease. So this is, Alzheimer's in the back, Parkinson's disease in the front, and schizophrenia is more in the front.
Wes, I'm sorry to interrupt, but now that you're bringing up Alzheimer's disease, I was wondering maybe there's some practical things here that we might bring to our audience about how do we keep our brains fresh and ready and have wonderful long lives with clarity and good memory. I was looking at a report that you worked on, not a report, but a research paper that was published with you and your colleagues this summer, I believe, July of this year. You worked on some point of care testing. Is that correct? I think it was
testing?
Well, it was MEMTRAX. It was point of care,
memory testing.
Early testing in to people that could make it more accessible, right? Because I feel like oftentimes it's quite further along in the Alzheimer's and or some memory issue problem before families get to their primary care. And what can their primary care do? They're going to refer you off to neuro, and a long road of testing. And often our patient starts understanding what's happening and then pulls the plug on that, and they don't move forward because they're afraid or for whatever reason. But I did read about MEMTRAX, something that you worked on, I think, long before this summer, as well as some maybe some biomarkers and maybe even some scans. So can you talk about that? Is that something that we're going to be able to walk into our doctor's office and have an easy way to see if we are at risk?
I took the MEMTRAX test, and 98%. I qualified 91%.
What did you get?
98%. I'm one of the top 20% of that.
I did. I got 97.
You have to try it.
I did it. I got a 97.
My son knows about it. My son is a neuroscience guy, and he knows about this test. All the students know about this test, Dr. Ashford. It's very well known among kids and among the neuroscience graduates. Your test, very well known.
Yeah. So what I was telling you was that I was directing this ward and seeing all these patients with Alzheimer's disease. It was in the temporal lobe. And so I was studying through 1984. I finished my dissertation in 84, where I was doing all this stuff that I was telling you about. That's all monkey work. But during that same time, I went from 2 years on the geriatric psychiatry unit down to spending 5 years directing the geriatric psychiatry outpatient clinic. And we really did the first PET scans on Alzheimer patients for patients that I was seeing in our outpatient clinic. I was interested in how the brain worked and this PET scanning thing. There was a guy named David Kuhl who was doing this, and I went and listened to him talk about they were doing PET scans and some other group of people. And I said, well, can we do them in my Alzheimer patients? He said, well, yeah. Can I come down to your office and talk to you about it? And so he showed up in my office. And so we did the first PET scans on Alzheimer patients. And they have loss of blood flow and metabolism, and I've published a few papers on this, in the temporal lobe and the hippocampus. And that's been widely replicated. That's not, nothing new. But the question was, well, okay. So I was interested in these patients I was seeing, and I was testing them with this antique test that I wish people wouldn't use anymore, called the mini mental state exam. I'll bet you've heard of it, Susan.
Yes, I have.
1975 test. And it had just sort of come out, and I was giving this to all my patients. It's like, well, what I'd been doing first is I was saying to my patients as I was seeing them, I say, and I usually have a nurse or two in the room with me when we're doing a family member, maybe I say, okay, I want you to remember 5 things. You remember apple, table, penny, rug, chair. And they say, can you remember those? Oh, yeah, no problem. You come back a few minutes later and say, what were those 5 words I asked you to remember? What 5 words? And that was, I couldn't believe it. But this was exactly what we were looking at in the monkeys. And so as we tested we were looking at the mini mental state exam. It turns out the items on the mini mental state exam that are most related to having early dementia, not late dementia, because they're gone by late dementia, are those 3 items and knowing what the date is. So if you can remember 3 items after distraction and the date, you're probably okay. Then later this MOCA test came along, which is only slightly better, if at all, and it's got 5 words. And then there's all sorts of other word memory tests to try and test early. And I was interested in this issue, but I don't know if you've ever taken one of these tests, but once you take one, you never want to do it again. It's like, okay, repeat 10 words. Oh, good grief. No, repeat them again. Oh, no, not again. It's like, okay, 5 minutes later, what were they? Oh, geez, I don't know. You know, those are tough. So we ended up using a picture test. It was a continuous recognition test where you just show a series of pictures and say, did you see the picture before? And people like it. We've had a couple of million people take that Memtrax test because it's not bad to take. And we have 3,000 different pictures. And
what the test tells, Dr. Ashford? What is the test reveals? Is it if there is advanced Alzheimer's disease there? If they can't repeat that, does it?
Well, the problem with Alzheimer's is you show them something and it does not get encoded into their memory system. The P300 I talked about, that brainwave when you're surprised about something, doesn't occur. It gets wiped out early in the illness. So they see something, it's like, yeah, but it doesn't stick. So the Alzheimer patients miss items, lots of items. They just don't remember seeing it. The patients who have frontotemporal dementia or problems with controlling their enthusiasm have too many false alarms. And then so we can measure if they're more frontal lobe problems or more temporal lobe problems. And then we can also measure their response time to see how quickly they're doing. And we're basically saying, are you within normal limits or are you not within normal limits? Because I don't see this as a full test. This is a screening test. It can be done in 90 seconds. You can use it to measure drug effects and things like that. We've had people take this 100 times in one day. And we've had people who've taken it thousands of times.
And it's fun. It's fun. It's not intimidating. So, you can take this imaging, you can get some labs. Now, those 2 things aren't going to scare anybody away. So a little picture game, not the memory one that hurts, that they're never going to come back, because you scare them away with that. I've had a family member, we went through every one of these tests, and he wasn't going back, right? He did not like it, and he wasn't going back. His disease progressed, and we never got, the treatment he needed early, and then it was late. So how about some practical applications? What do we what are we doing today? I mean, how much of this is genetics? How much of this is nature versus nurture? And what can we do? What can we do?
How do you prevent it? Yeah.
I'm not going to tell you my bad joke again, but the biggest factor in Alzheimer's disease is the apolipoprotein E gene. And it turns out that the people who have a 4/4 are most likely to get Alzheimer's disease around 67 years old. And the people who have one of those, an E3/4 and E2/4, most likely to get it on average about 76 years old. And the people who have an E3/3, most likely to get it around 85 years old. So there's like a 9-year jump every time you get one of these genes. And then there's something on E2 gene, which is not good for other reasons. That a lot of people make it to 100 to have the E2 gene. So there's a genetic factor that's huge in this, and there's other genetic factors too.
These are the genetic test. We can take it, right, Dr. Ashford? This test is available.
You can go to 23andMe and find your ApoE genotype, and then you can take this test and see how your memory is. But okay, so all right, so there's genetic factor. It's been very hard to change your genetic. The Down syndrome kids all get Alzheimer's disease. The changes in their brain occur in their 20s. That usually have dementia in their late 30s or 40s. And this is unfortunate, but it's because the fundamental gene involved in memory is on chromosome 21, and Down's, is called trisomy 21.
Yeah.
And there is a gene. It's less than 1% of all the genes associated with Alzheimer's are related to that gene, but there is this gene, the amyloid precursor protein, that is highly related to Alzheimer's disease. But the problem is right now in the field, there's a book called Doctored I highly recommend. It talks about the NIH and drug companies spend $100 billion trying to study amyloid and how you get rid of it. And I knew the people involved in this. And, some of them are pretty serious, but that's not explaining Alzheimer's. Alzheimer's disease is a disease of neuroplasticity. It's a disease of the fundamental memory mechanism. Now, the
That is
amyloid
where you are really played a very significant role, Dr. Ashford. I think I was so impressed with that thing. You said that it's not amyloid problem. It is not that kind of a tangling problem. It is something dynamic neuroplasticity. You are the very powerful statement.
We proposed that in 1985. That was a long time ago, but turns out that is correct. And the thing is that it's the amyloid precursor protein, I think, is the fundamental protein involved in neuroplasticity. And if you have to activate the amyloid precursor protein. To activate it to make new synapses, you have to stimulate it. And the three neurotransmitter systems that stimulate it are norepinephrine, serotonin, and acetylcholine. You've heard of these, Susan. The neurons are based in the brainstem and project to the cortex, and they activate the amyloid precursor protein with something called an ADAM10 to form a nexon to form new synapses. And this is occurring, like I said, at a rate of 10 trillion per day. But if you don't activate that ADAM10 at a particular location because it's not relevant anymore, the default is the beta secretase, which forms the beta amyloid, which tracks the synapse. So you have some synapses going out and forming new ones, and others that are retracting and getting rid of them. It's a dynamic process.
How do we activate them? This would seem to be a very
good
important part. How do we activate them? I'm taking notes.
Yeah, okay. One bad piece of bad news for you. One of the things that most highly correlated with Alzheimer's disease is retirement.
Oh, retirement?
What is it?
Retirement.
No problem here.
Well, it's I mean, the thing is, how do you prevent Alzheimer's disease? I mean, so one of the things I said right away is that during the brainstem is controlling things. And the question is, are you keeping your brainstem healthy? And there's a genetic factor. We need to know what that genetic factor is and how to overcome that. And it turns out that ApoE I'm talking about is the cholesterol chaperone. So what I was doing with cutting the fat off my steak was actually one of the things to prevent Alzheimer's disease. You want to keep your cholesterol low. And most of the patients we see have elevated cholesterol. And I'm sorry they like their steak so much, but it's tough life we live in. Yeah.
What about turmeric? Turmeric has any? Yeah, I heard about turmeric as a very good. Is it reduces the progression of the Alzheimer? Is it a myth or real?
I don't know. There's some people at UCLA have studied this and think it's great. My wife thinks it's great, but I haven't quite read enough on it yet. Okay. Turmeric, but clearly exercise is very good. There's been several studies showing that that you get enough exercise. It doesn't have to be a lot, but it has to be, it has to be the right type of exercise. That delays Alzheimer's disease. We published a paper in the 90s that if you had 4 years of education and got a college degree, you had a delay of your Alzheimer's disease by 4 years relative to those who did not go to college. That was done with a series of nuns. So going to college is good. Getting educated, keeping your mind active is a very important thing. Getting plenty of exercise seems to be good. Although one of the important things is getting enough sleep at night, because it's during the sleep that you get rid of the byproducts from those synapses that were being removed.
So when start at the beginning with the SHIELD, because you've named a couple of your SHIELD. And so this was a wonderful acronym for our listeners to categorize these things that we can do by putting up our SHIELD, our healthy SHIELD. And then you started with S, which was sleep. Yes, good memory. So and then there was SHIELD HI, but you combined them and they were, this is where I failed. Head injuries, traumatic brain injury. You want to hit your head, traumatic. And this is a problem we have with our veterans all the time because they have had head injuries. You need to protect your brain. You need to wear a helmet if you're riding a bicycle. I'm sorry if it's not cool, but you need to do that. Probably need to stay away from motorcycles. Boxing, probably not as good a sport as you think it is.
And even football is problematic. And you get
Yeah.
CTE, and then they get demented. And and another serious problem, particularly for older people, is you want to be careful of the rugs in your house. You don't have trip hazards.
Oh,
My
everywhere.
grandfather died tripping over a curb on his way back from the grocery store when he was 89, walking.
Yeah, that's a shame.
So
And then
you got to
E was an easy one. E for exercise. We all know that, right? So
exercise. E is
SHIEL.
exercise. L is learning, keeping your
Oh, that's
brain stimulated.
use it or
And D
lose
is
it.
the one no one wants to talk about. Actually, D stands for donuts. You got to eat as many donuts as you
Do
can.
not
Oh my God.
No, I'm kidding. It's diet. You got to have
diet.
a healthy diet.
And so that was, and specific, I mean, without getting too crazy about the nutrition, but it was, keeping the cholesterol low. So maybe keeping your animal products to, a healthy minimum.
There's something called the Mind diet and the Mediterranean diet, and there are all these blue zones where that's what they eat, and they don't get very much Alzheimer's disease there, and they live longer. So there are things about that. Now that's not all, but that's a good start. Another thing that's extremely difficult to do is follow your doctor's orders. So if your doctor says you got hypertension, you got to take these pills and get your blood pressure down. That's important.
Yeah.
So there are some things about, we've got to get your cholesterol down. I'm sorry about that. These are your doctor's going to tell you. You don't you don't want to get overweight. Being obese is associated with Alzheimer's disease, and obesity and diabetes both.
What do you think the most mystery of the mind or brain? What do you think what do you think that it's a puzzle that is there? Is very hard to understand and brain itself or the mind. One of the questions I want to ask you is the mind and brain or the consciousness is coming from the brain itself or consciousness is independent. There's a lot of psychology says consciousness is independent of brain, but according to you, brain is a mind is a consciousness.
Consciousness is in your brain
emergent
stem,
property.
in the lizard brain.
The
You're
lizard
either
brain.
awake or you're asleep. I mean, is that so mysterious? If you're conscious, you're awake. You're asleep, you're unconscious. Okay. I mean, that's so difficult to understand. I've never always had people, oh, where's consciousness? How do you understand it? It's in the brain stem.
We should have been more, I think the mind-blowing fact of the evening was the number of neurons themselves and connections. You guys gave a number that was what was the number? To the 10th of the zillionth, to the jillionth, to the...
That's out of this universe.
Power is a big number.
That's a big number.
The capacity of your brain.
Can we ever, there isn't even the potential to tap that, right? I mean, so there's infinite amount of learning, right? I mean, just infinite. There would be no way.
Yeah,
to
well, so
use them all.
there's another problem I haven't talked to you about. The difference between boys and girls is that the problem we've had going from being chimpanzees to being humans is that our heads have gotten bigger. And I don't mean that,
facetiously.
really physically it's gotten bigger. That's not just allegorical. But as it's gotten bigger, there's been a problem. That babies have to get outside of the woman.
Indeed, they do.
And that has been a huge issue. Ashley Montague talked about this, that women had to get their hips to be a little wider, and the babies had to be born younger and younger. And because of that, the women had to get bigger and bigger breasts. So that's just evolution. And as this happened, it allowed the brain to have also a longer period of development time. So you were born, you're 2 years old, you're 10 years old, you go through maturity. And then, Freud said you couldn't psychoanalyze people after 30. And the thing is up until 30 years old before your frontal lobes really settle in and decide to not, pretty much that's what your personality is going to be. So the brain goes through a tremendous amount of development before you're born and then after you're born. And I mean, it's like language. I'm here. Romano was complaining to me about his accent. I said, not that bad. But he has an accent because he wasn't born in this country and he came here later. And his brain was not able to adapt to that, to having a flawless accent. I've seen a lot of people who were born in this country and they don't have an accent. It's got to do with the brain's period of critical periods when it can learn things, and after that, it can't learn things. And there's several areas of your brain that are like that they just can't learn anything new. But in the course of that, you learn all sorts of things. Now, I don't know. Do you remember very much it happened before you were 2 years old?
No.
No, because your brain is forming all sorts of tremendous numbers of new connections, but they're not forming things that are going to be part of your long-term awarenesses. Once you get to be about 2 years old, you start developing awareness. You become aware of your mother and your father and, mama, dad, and then later you're aware of other things. And your consciousness is something that in this aspect, your mind is something that's developed over the course of your life.
Yeah.
And, of things that you learn and remember and you become aware of. And
I'm
then you're aware of it.
Yeah. I'm interviewing a kid, science prodigy, 10-year-old, 11-year-old kid. One thing he said that he was talking with the CNN Sanjay Gupta. He's saying that, if I give you all the powers, what do you want? He says that I want infinite memory. He said that he wants
Infinite memory?
Yeah,
Infinite memory.
that is infinite storage. He wants the
Yeah.
infinite storage. He's at 6 months old. He started reading everything there. His child prodigies. Do you learn anything from child prodigies? Where these anomalies coming from the brain?
There's a book called The Mind of a Mnemonist, mnemonist being a person that remembers, by a guy named Alexander Luria, one of the great neuropsychologists from Russia. And he had a guy who could remember everything. He first noticed him because he was a newspaper reporter, and he would remember things, and he wouldn't take notes because he remembered everything, word for word. You give him a list of 50 numbers, and he would remember them. He'd remember them a week later. He had a perfect memory. He wasn't very smart, but he had a perfect memory. It can happen. Your brain does have that capability. But the problem is, you've got to forget some things. You've got to, keep learning what the processes are.
So, Dr. Ashford, I want to ask you, when you bring back memory, like my father, some incident, my father took me to a movie, Julius Caesar, and I remember that vividly when I was a kid. A Cleopatra movie I saw that my father took me. I wanted to ask you that memory, when I was recreating, every time I recall that memory, am I recreating that? Is it somewhere stored, or am I recreating every time I recall that memory? It's changing every time, dynamic way. I'm putting the new stuff together.
Well, the details of that are lost in your brain somewhere. But I mean, you can definitely go to a movie and you can remember a large amount of the movie. And you can go back and see the movie a second time and say, wait a minute, I remember that part and that part and that part. Or if they change something, you might even notice it. And all of that information gets stored in your brain as it's occurring. And that's part of the 10 trillion synapses I talk about. But if you try to go and recollect it, or you try and remember, 10 words or something like that, your frontal lobes have to then go and do a search for it. And that's where I was saying that you've got the posterior part of your brain, back part, it's where the stuff's stored. The front part is where you develop thoughts. And part of your thoughts might be, wait a minute, I need to think about what were the things that I remembered in that movie. And then your frontal lobes go back and start picking through the information. There's lots of connections between the front and the back. They start trying to go back through and pick there and try and see, well, what are the things that I can salvage in the way of memories of something like that.
And isn't it true, Wes, that some of these memories and some of these file folders back there are flagged because of the emotions that were evident at the time of the memory? So if it was particularly fearful, particularly dramatic, that memory has a more clarity, that it's an easier memory to find. I know I've heard of studies where children, maybe in Germany, they were having to do their studies and study for an exam, and then they would shove these kids in the icy river, and then they pull them out. They remember everything because they would attach the memory of the freezing cold water that it flagged that file. So it's kind of a funny example. But what do you think of that?
Well, we see too many patients with PTSD at the VA, I'll tell you that.
I bet.
And the question is, what is PTSD? And what I'm unfortunately going to tell you is I'm going to go right back to the brainstem. Because what happens when you see these terrible things is the brainstem, the back part of the brainstem acts as a sentinel, like it did in my PhD dissertation. And it's like, whoa, this is something that's happening that's very bad, and we're being alerted to it. And then what it's doing is it's so stressful that it activates the brain to form extremely powerful memories that are not easily forgotten. And the amygdala, which tells you whether things are good or bad, is the sort of the Ronald Reagan area of the brain, tells you if good things are good or bad. It says, okay, these are things that are important, they're very bad, we need to remember them, and they get encoded in billions and billions of synapses that are encoded very strongly. And they're not easy then to put aside. And maybe more, as I say 10 trillion a day, maybe in one particular instance, it'll be more, because there's so many terrible things that are getting put into the brain, and then they're going to pop up occasionally. And if there's something that reminds you of them, then they're going to be right there. So traumatic memories are not good.
It's kind of late in the show to bring up a topic, but I'll just throw a little mini curveball. But to that effect, I know there's a lot of new clinics popping up offering mini and microdosing of psychedelics in order to help erase those tracks, those memory tracks that are like, frozen in the snow, like ski tracks in your brain, where people with traumatic thoughts are having, a repeated route down that icy packed in track, and then little bits of psychedelics are like fresh snow, like fresh powder, and helping them perhaps stop that runway from happening. Any thoughts on psychedelics and kind of making a clean slate?
Well, it's a subject that I don't do very well with. I was at Berkeley, and I told you that. And a lot of people there, including my roommates, were taking things like LSD and a bunch of other things. And I wouldn't touch the stuff with a 10-foot pole, part of my wanting to live forever. Instead, what I did was I took physiological psychology classes trying to understand what they did. And I wrote a term paper on the effects of LSD. LSD has an effect on the brain that is almost identical to what happens to the brain during REM sleep or dreaming sleep. And I just think, taking drugs like that, I'm just sort of never, there's another story I could tell you, a really sad story about a guy who was studying this at Stanford that recently killed himself. And I just, I don't trust these drugs. I know they're getting very popular to do what you're saying. I've sort of avoided them. They may be much better than I think they are. But for patients with PTSD, and I've seen a lot, the drug I've had the most success with is something called trazodone, which is a very widely prescribed antidepressant drug that is good for sleep and not depression. But what it does is it increases stage 4 sleep, which is the REM sleep. And a lot of the patients I've used trazodone for get better sleep, and they stop having all these memories. And it's probably a similar mechanism without taking one of these drugs. But anyway, I've got a bias in there that may not be correct, but I'm just telling you what it is.
Truth be told, I think that there's every chemical that's produced from psychedelics, we could probably produce ourselves within our miraculous brain. There's probably a way for us to actually fix and cure almost many things with if we use our shield, and out with the old and in with the new, and maybe some Sudoku or something along those lines.
And get a good night's sleep. Because I think that during dreaming is where a lot of things are set right, and the things that are stressing to you, and it's the deep sleep, not the in between sleep, but the deep sleep when those things are resolved. Anyway, that's just my theory on it.
Dr. Ashford, Memtrax is memtrax.com, right? That's a website that people can go and test their knowledge and all those things, right?
MTRAX.
Yeah, we put on the under your name is there already.
Yeah, let's see, my son brought down.
Yeah.
Yeah, I'm going to take it again. I was a little tired.
Is that backwards?
Yes,
yeah,
it is.
mirror image that, but it's
No,
showing the mirror
no.
image. That's what. Yeah, Memtrax. Yeah, I took it, and very interesting. I think
Me too.
I will always encourage people to take it. Dr. Ashford, you're Susan. You can say a couple of words, and I'm going to say a final thing, and
Well, I think
we can talk with him whole couple 3-4 hours whole day, but we can bring him back.
Yeah, I want to live forever. Yeah, that's not going to work. But I also don't want to get demented. And I think that, you take good care of your health and everything, and you live longer, and then you end up getting Alzheimer's disease. That's what we really need to prevent. And I think that there's some things I suggested. There's a lot of other things, medications that are coming out. I don't believe the anti-amyloid drugs are useful, but there may be other cholesterol medications. It turns out that lithium, we may have a deficit of lithium that causes the development of Alzheimer's disease. And that's a strange one. And there's other chemicals that are out there that may help prevent Alzheimer's disease, and we need to know what they are so we can live older, be healthy. I mean, there's another problem. I talk about women. Women aren't having enough children, and in this country, I really believe I'm a pro-natalist. If anything, I believe in having children. I got 4 of them. And I think that we have to have children to take care of us when we get older, and maybe not to take care of us directly, but at least to pay their taxes so we have some social security. And if you don't have kids and no one's working, you don't have any social security. So there's got to be some balancing of the world. And I believe that we need to not have Alzheimer's disease, live longer, and get along with each other. So anyway, those are my beliefs.
Well, I can't thank you enough for the education tonight. It's fascinating, your knowledge. We could really talk for hours and hours on just any one of these singular topics. Our brain health, the shield, very practical. The mem tracks, I think, was very handy. The fact that you could get a 2-minute or less test plus a couple labs, and that's a very entry level way for people to find out if they're going down the wrong direction and get help early. I know that's a real problem. So I can't thank you enough. We're going to have to talk again. I have lots of more questions about my brain and how it's working, how it's holding in with the new.
Thank you, sir.
Conspiracy theory.
Oh, yeah. See, I forgot already.
Thank you, sir. Truly an honor and privilege.
It was a pleasure. I enjoy talking too much.
Meeting you in person.
Not at all.
Meeting you in person was a blessing. You are truly educational. You are a revolutionary in the idea of bringing a new ideas to the science of mind. So I think you're very powerful in that your contributions are really notable.
Thank you very much.
Thank you, sir. And stay on the course, and we close the program. But we can talk with you after the live show.
Right, I hope your audience appreciated it too.
Thank you, sir. We'll keep coming here. We wanted to bring you because this is a very important topic. The people are getting older, and then everybody is afraid of the Alzheimer's.
Oh, I got one more piece of bad news for you. Every year you get a year older.
Oh,
what a
spoiler alert. Thanks a lot, Wes.
That's a powerful wisdom. Good night, all of you. Good night. With Dr. John Wesson.
We are retelling their stories through our patented designs that can be worn on scrubs, t-shirts, printed on conference bags, and endless other promotional materials. Daily Wear for Medicine is the first ever of its kind to create curiosity in medicine through visual art. We at MedBricks are celebrating unsung heroes of the past who made enormous contributions to the field of medicine through our unique campaign called Daily Wear for Medicine. You can wear it, carry it, and give it.